by sine 40 degree. From here we can get our W parallel already. So 10 times 9.81 times sine 40 degree. So we have 63.1 Newton. Okay, 63.1 Newton pulling the object down. No friction. Okay, no friction. So now you look at the whole scenario by making your head 40 degree. We assume that one is a downward motion. Okay, the downward motion. And you see, to reach the base here, the object need to move 3 meters. So when you release, okay, U is equal to 0. See or not? U is equal to 0. And it is moving a distance of 3 meters with an acceleration which is not yet calculated. We can calculate the acceleration later. Acceleration can be calculated based on the force divided by m, which is equal to this force, 63.1 divided by the mass of 10 kg, which is 6.31 meter per second. And then you need to calculate the final velocity and also the time. So these are the two things that you need to calculate. So to calculate the first one, V, you are using this one. V equal to U square plus 2AS. So V square, U is 0 plus 2 times 6.31 and then displacement of 3. Okay, displacement of 3. So 2 times 6.31 times 3 and then don't forget to square root. Okay, now we have 6.15. 6.15 meter per second. Alright. That is how fast the object when it reaches the bottom of the inclined plane. And then for the time, so now for the time, we cover this one up. Now we have USAT. You want to calculate the time, you have to use this one. S is equal to UT plus half AT squared. So this one is 3, this one 0, plus half times 6.31 and T squared. Alright. So we calculate 3 times 2 and then divide by 6.31 and don't forget the square root also. Okay, so that is like very long. Okay, sorry, very short time. Okay, very short time. So am I correct or not? S equal to UT plus half AT square. So this one multiply by 3. Calculate again one more time. 3 times 2 divided by 6.31. Okay, square root. I get this. Okay, correct. So the T is 0.98 seconds. Almost 1 second. Okay, almost 1 second. So this is our answer when there is no friction. Okay, when there is no friction, right? Now the next one is when there is a friction. That is B. So we need to draw the same diagram again. Angle theta 40 degree. The same object here. Well, the force downward is still the same. Okay, exactly the same. W parallel. This one 63.1. And then we have another force. Friction. Okay. Now it has a friction F of 4 Newton. Okay, F of 4 Newton. Will it change our scenario or not? Well, we check and see. First one, V square is equal to U square plus 2AS. V square 0 plus 2. Now our acceleration will be different, right? Oh, sorry, we have to calculate our acceleration first. Because the force already changed. Okay, the force already changed. So needs F is equal to MA. So now the force is 63.1 minus 4 is equal to 10^8. So our A, new acceleration is this one. Okay, 63.1 minus 4 divided by 10. So we have 5.91 meter per second per second. That is our new acceleration. So now we use the same formula. V square U square plus 2AS. So V is V square is 0 plus 2, 5.91 times 3. So our V will be, now it's different. So you have 2 times 5.91 times 3, and then square root. We have this 5.95 meter per second. Definitely slower than this because of friction. And the next one is S equal to ut plus half at square. This one is 3, 0, half 5.91 t square. Okay, so you have 3 times 2 again, but now divide by 5.91 and then square root again. So answer is 1.01 seconds. See, with friction involved, things get slower, take a longer time to reach the base of the incline. Alright, so this one you can consider as a very difficult question. Alright, very difficult question. So that is chapter 4 for incline. Alright, keep updated for chapter number 5 and 6.